toy company has designed a new toy that uses a spring and follows a sinusoidal curve after you wind it up and starting it. At T5 seconds, the toy is at its highest point, which is 18 centimeters above the ground. 4 seconds later, the toy is at the lowest point, which is 6 centimeters above the ground. Find an equation that will determine the height of the toy at any time, t. The tasks that were given to us were A. Find the height of the spring after 26 seconds. B. Find the first time the height of the spring reaches 16 centimeters above the ground. And we had to come up with two other problems, which are C and D, being what would the height of the frog be after 10 seconds prior to t equals 5? And D, how would the graph look if the equation given were to be 6 cosine of pi over 4 x minus 1 plus 12?
First thing we need to do is define the graph. So we know the maximum is 18 seconds and we know the minimum is 6 seconds. So we need to find A with that and the midpoint with that, K, which we have here, and we're about to show you how we got that. The way we find the midpoint is we add the maximum to the minimum. So we add 18 plus 6, which gives us 24. Next thing we do is we divide 24 by 2, which gives us 12. So that's how we know the midpoint. Must find b of the equation, and the way we do that is we do 4 times 2, which equals 8. Reason why we do that is because we know it takes the maximum to go to the minimum in 4 seconds. And so from the minimum to go to the minimum again would be 8 seconds. And that's how we know 8 is equal to the period p. Then we know that 8 is equal to p. We plug that into p equals 2 pi divided by b. So 8 would equal 2 pi divided by b. And you multiply b by both sides because we're trying to get b by itself. So 8b is equal to 2 pi. Then we divide by 8 because once again we're trying to get b by itself. So b would equal 2 pi divided by 8. So now what we do, since we see that these two are very similar, by 2, make this into 1, make this into 4, and we finally know that b is equal to pi over 4. Now that we have almost everything, we need to find h. So the way we find h is we know that the highest went to the lowest 4 seconds after. So we must find the lowest to the highest. So so x would equal 5, and it was at 18 centimeters. So if we go minus 4, it would go back down to 6 centimeters. And 5 minus 4 is equal to 1. So that's where we're going to start it with h is equal to 1.
Now for the final part of the equation, we need to find a. The way we find a is we do the minimum and the maximum and the midpoint. So the way you get to the midpoint is you do the minimum plus 6 to equal 12. And the way you get to the maximum is 12 plus 6, which equals 18. So we know that a has to be 6. But it's going to be negative 6 because we're going to start it at 1, t equals 1, and at that point it's at the lowest point, which is 6. So since it's a cosine graph and it starts at its lowest point, it's going to be negative 6. Now that we have all the parts, we can finally make our final equation, which is y is equal to negative 6 cosine pi over 4 x minus 1 plus 12.
Well, now that we have the equation and we know what each of the parts in the equation mean, we could start labeling the graph. And for that, we could probably go by sixes since we know that the midpoint is 12 and we know that our minimum is 6 and our maximum is height. So it'll be better off if we go by sixes. 6, 12, and 18. And then for the x-axis, since we're talking about seconds, it would probably be better if we go by ones. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Since at 9 the whole cycle is complete. Well, as we said before, the k is the midpoint, which means our k would be 12. So let's just draw another line so we can know where it is located. After that, we're going to be labeling the points in our graph. So first of all, since the frog started at 1, 6, we're gonna label 1 and 6 with probably red color. That'll be better. Around here. And then it jumped and it got to 18 centimeters high uh, during the 5th second. During the after 5 seconds, after 4 seconds, I'm sorry. 3, 4, 5. So it'll be around here. So this, remember, this is just a sketch, since it's almost impossible to do the right one in the computer. Um, After that, the frog went back down to, again, after 4 seconds after the starting point, as the highest point. After 4 seconds, it went back down to the lowest point, the minimum point. So it'll be 9, 6. And now we just connect the points, and it's a negative cosine. And as my partner explained it, it was shifted pi over 4. I'm sorry. It was shifted to the right by -1, which in this case would mean that it's going to the right by 1. Um, and b, meaning the frequency, it's going to be pi over 4. The amplitude, as you guys can see, -6 was chosen because I'm sorry, -6, since it started at the minimum point, meaning that the graph would be a cosine, and it went up by 6 units and then reached the midpoint, and then it went up by 6 units again to reach the highest point. So that's how we found out it was -6.
We have our equation and a graph, we can find A, B, C, and D. So question A asks us to find the height of the spring after 26 seconds. So we need to plug in X for 26. And since our graph isn't so good here, we're going to pull up another graph with Desmos. So here we've already graphed it, and 26 seconds is about here. So we already have this equation here, so I'm going to do X equals 26. So that's where it should be right there. So now if we just control V, we plug in 26 instead of X, we can find that the height Y is equal to 7.75735931288. So now we can answer B, where we find the first time the height of the spring reaches 16 centimeters above ground. So then we know that Y is equal to 16, and we have to find the first time X is equal to 16. So let's pull out our graphing calculator. So here we already have Y is equal to 16, and this is the graph for it. And then we see here that this is 0, so the first time it reaches is about here, which is 3.929. That's our answer.
Part C, it's asking what would the height of the frog be? Basically, 10 seconds prior to T5. We have T5 right here, and we want to go 5 seconds before. Oops, sorry. And then another 5, which is going to leave us on -5. And we want to know what the height would be once we get here. So for that, we could use our calculator and input X. Oops. So what we do with the calculator is that we go to the x-axis and then we make it equal to 5 because that's where we know our x-axis is. -5, I'm sorry. And as we can tell, the height would be negative, I'm sorry, 12. So at -5, the height of this would be at the midpoint. For D, how would the graph look if the equation given were to be 6 cosine of pi negative over 4 x minus 1 plus 12? Basically, it's similar to the one we are given already. We just changed the sign, the negative sign into a plus sign in front of the cosine, which is going to make it look like a simple or as a basically as a parent graph in our um our graph. So instead of starting at the minimum point, it would actually start at the maximum point. Then uh the highest point would be located at the minimum point, and then the last minimum point would be located at 18, which is our maximum point again. And then where the lines touch the zero, I mean the midpoint on the -6 cosine equation would be the same as the 6 cosine equation. So that's how the graph would look if it were to be flipped or changed into a negative cosine.